Hello and welcome. Today we will be diving into the fundamentals of SQL or structured query language. This tutorial is designed for beginners and covers essential concepts of SQL. By the end of this tutorial, you will have a fundamental understanding of SQL and the ability to perform basic to intermediate operations on relational databases. So, let's get started. In this tutorial, we will discuss the following topics. We will learn what is SQL and where it is used. And also we will learn how SQL evolved over time. We will learn about databases, especially relational databases. We will discuss what are primary keys and foreign keys. We will learn how to create tables using SQL and how to perform basic operations. Also, we will be discussing advanced topics like joins. So, what is SQL? SQL stands for Structured Query Language. It is also used as SQL. SQL is a query language specifically designed for accessing and manipulating relational databases. Simply, SQL is a language that lets users interact with relational databases. Think of SQL as the bridge between you and your data. It's used across industries, whether in healthcare, finance, e commerce, or tech. SQL skills are highly in demand in today's job market. In 1970, Edgar F. Code, a computer scientist at IBM, introduced relational model. This revolutionary concept proposed organizing data into tables with rows and columns. Building on Code's idea, Donald D. Chamberlain and Raymond F. Boyce developed SQL or Structured English Query Language in 1974. SQL was later renamed to SQL or Structured Query Language due to trademark issues. By late 1970s, SQL became the go-to language for managing relational databases. In 1979, Oracle released the first commercial implementation of SQL. The success of SQL prompted standardization. By 1986, SQL became an ANSI standard. So, what is a database? A database is an organized collection of data that is stored and managed electronically. Now, you know what is a database. Then, what is its purpose? Database allows for efficient storage, retrieval, and manipulation of data. In databases, data is typically stored in tables with rows and columns for easy access. So, what are all the types of databases available? We have relational databases, NoSQL databases, and cloud databases. Relational databases use structured tables, whereas NoSQL databases handle unstructured or semi structured data. Then we have cloud databases. Cloud databases are hosted on cloud platforms for scalability and accessibility. Some of the uses of database includes storing customer information in e-commerce, managing inventory in warehouses, keeping patient records in hospitals, etc. The key features of database are data integrity, security, and scalability. Data integrity ensures accuracy and consistency. Also, database protects sensitive data with access control. That's meant by security. Scalability is the ability of a database to handle increasing amount of data, number of users, and type of request without sacrificing availability and performance. Popular database management systems include Oracle, SQL Server, MySQL, and MongoDB. So basically, a database is an organized collection of data that is stored and managed to ensure easy access, retrieval, and manipulation. It is a crucial component in software systems and applications, allowing users and programs to work with large amount of information efficiently. We have discussed about databases and its type. Let's now look at the basics of relational databases and see how it works. A relational database is a collection of data stored in any number of tables. The tables are made up of rows also known as records, and columns, known as field or attribute, where each table focuses on a specific type of data, like customers, orders, or products. In common usage, the term relational indicates that the tables are usually related to each other in some manner. The tables in a relational database can be linked through keys such as primary key and foreign key. These topics will be discussed in detail later in this tutorial. SQL is used to manage and manipulate data in a relational database. The most popular relational database systems are MySQL, PostgreSQL, Oracle, Microsoft SQL Server, and SQLite. Have you ever wondered why relational databases are most popular? One of the main factors is they provide efficient storage and retrieval of data. They also provide scalability for growing datasets. That means RDBMS can distribute data across different servers. Also, RDBMS support complex queries and data analysis. SQL is divided into several components, each designed for specific tasks. Let's dive into each one. The first component of SQL is Data Definition Language or DDL. DDL defines and manages the structure of a database. The common commands that are associated with DDL are create, alter, drop, and truncate. The create command creates new databases, tables, or other objects, whereas the alter command modifies existing database objects like tables. The drop command is used to delete database objects such as tables or databases. The last one is truncate. The truncate command removes all records from a table while keeping its structure. The difference between drop and truncate is that the drop command deletes the entire table, but the truncate command removes only data from the table. The next component is Data Manipulation Language or DML. DML is a component of SQL that enables efficient data manipulation in databases. In other words, DML deals with modifying the data stored in a table. DML helps the users to interact with data efficiently. The commands that are associated with DML are insert, update, and delete. Insert command is used to add data to a table. Suppose you want to modify existing table, like if you want to change the data type or the column name, there comes the update command. So the update command is used to modify existing table. The next command is delete. Delete command is used to delete data from a table. The third component is DCL or Data Control Language. DCL manages user permissions and security. The commands that are associated with DCL are grant and revoke. A database is often used by multitude of users, each with different roles and responsibilities. However, these users should not all have the same level of access to the data within a database. This is where the grant and revoke statement come into play. Database administrators use grant command to provide access to users, whereas the revoke command remove access from users. The fourth component of SQL is Transaction Control Language or TCL. TCL manages transactions to maintain the consistency and integrity of the database. The commands that are associated with TCL are commit, rollback, and save point. The commit command is used to save the changes made in a transaction. Rollback command undoes the changes made in a transaction, whereas the save point command creates a point within a transaction to roll back to. These components collectively allow for the creation, management, manipulation, and secure handling of data in a relational database. Each of these components serve a vital role in database lifecycle. What happens when you enter a SQL command? How it fetches data? Come, let's explore. SQL works in a sequence of steps to execute a command. Let's imagine a user submit a select query to retrieve its customer ID from the customer's table. Now, the SQL engine processes, optimizes, and executes the query. As a next step, the DBMS accesses the relevant data and returns the result as a table view to the user. In summary, SQL functions as a bridge between users and the relational database, enabling the retrieval, insertion, updation, and deletion of data in a structured and efficient way. A data type specifies what kind of data a variable or column can hold. SQL data types specify the type of data that can be stored in a column. They help ensure data consistency and define how data is stored, retrieved, and manipulated. Here is a list of data types that is supported by SQL. Numeric data types store numbers, which can be integers, decimals, or floating point values, whereas the character or string data type stores text and string values. The date and time data type can store dates, times, or both. SQL also supports binary data type. The binary data type can store binary data like images, audio, or video. SQL also supports Boolean data type. In Boolean, the value is stored as true or false or null. SQL also supports some special data type such as JSON, XML, enum, etc. When you learn SQL, it is important to know about the constraints in SQL. So, what is a constraint? Constraints in SQL are actually the rules applied to a table column to ensure the accuracy and reliability of the data within a database. They enforce data integrity and specify how data should be inserted, updated, or deleted in a table. Here are the most commonly used constraints in SQL. The first one is not null. When applied, it ensures that a column cannot have a null value. And also we have unique. This constraint ensures that all values in a column are unique. The primary key constraint is actually a combination of not null and unique. Since primary key is one of the important constraints, a detailed discussion is included later in this tutorial. The foreign key constraint is used to establish a relationship between two tables. This topic is discussed in detail later in this tutorial. Another constraint is check. Check ensures that all values in a column satisfy a specific condition. The default constraint provides a default value for a column when no value is specified. We will have a deeper look into these constraints once we start our examples. Constraints can be applied at the column level or the table level. Also, constraints can be added when creating a table or modified later using alter table command. Another term that you will encounter more often throughout your journey with SQL is database schema. Let's check out what is meant by database schema. A database schema is the structure or blueprint of a database that defines how data is organized, stored, and related to one another. It specifies the logical view of the entire database. The database schema is categorized into two types: the logical schema and physical schema. Logical schema defines the logical design such as entities, attributes, and their relationships, whereas the physical schema specifies how the data is actually stored in hardware, including table, indexes, and partitions. Schemas help ensure consistency, organization, and clarity in database design. As an example, let's take the simple case of a database consisting of only two tables: customers and orders. The customers table contains records of customers who ever placed an order. Then the order table has one record for each order. The common custom is to display the table as a grid of rows and columns. Of course, this example is highly simplistic and only hints at the type of data that could be stored in a real database. For example, a customer table would normally contain many additional columns, such as city, state, zip, etc. Similarly, an order table would contain columns describing additional attributes like order date, sales tax, etc. I think these two tables are good enough to learn the basic SQL commands. Just think about any IT companies. Each employee in the company is assigned with a unique employee ID. Each employee in that company can be identified with that ID. Similarly, primary key is a unique identifier for a record in a database table. Primary key ensures that each record in the table is distinct and can be uniquely retrieved. We learned what a primary key is. Now we can check the characteristics of a primary key. Each values in the primary key column must be unique across the table. Primary keys are immutable. That is, once a value is assigned for a primary key column, it doesn't change. A primary key column cannot contain a null value. Have you ever heard the term composite primary key? Here, in the customers table, the customer ID is the primary key because it uniquely identifies each customer in the table. Here, the primary key consists of only a single column. But sometimes, primary key can be composed of multiple columns. In some tables, primary key is a combination of more than one columns. A primary key that is composed of more than one column is called as a composite primary key. Now we can learn about foreign keys. What is actually a foreign key? Foreign key is a column or a combination of columns in a database table that establishes a relationship between two tables by referencing the primary key in another table. Maybe it will be easy to understand with an example. Let's say we have two tables, customers and orders. The customers table contains information about customers and the orders table tracks the orders made by each customer. We use foreign keys to link these two tables. The field customer ID was the primary key in customers table, but in orders table the field customer ID is the foreign key. This ensures that every order in the orders table belongs to a valid customer in the customers table. Now we can see what are all the characteristics of a foreign key. A foreign key creates a connection between a child table and a parent table. One of the most important characteristics of a foreign key is that it enforces referential integrity. This means that the foreign key value in the child table must match an existing value in the parent table, or it must be null. This ensures that there are no orphan records. An orphan record is the data in the child table that does not have a corresponding parent record. Consider our example. In the orders table, we have the customer ID 1, 2, and 3. We have the records for these customer IDs in the customers table too. Suppose I create a record in the orders table with the customer ID 4. But there is no customers with an ID 4 in the customers table. So the order details with the customer ID 4 in the orders table will be considered as an orphan record. Foreign key will not allow you to create an orphan record. Every foreign key must reference a unique column in the parent table. Typically, this is a primary key or a column with a unique constraint. So, to conclude, foreign keys are vital for maintaining the structure and reliability of relational databases. We have covered the basic concepts and the groundwork is done. Now we will go through some practical cases. In order to begin with, we need to install an IDE. You can choose any IDE that supports SQL. Here I am using MySQL Workbench. For that, you have to set up MySQL. You can download MySQL from their official website. Just follow the guidelines provided in the website to install MySQL. Once the server is installed, we need to download MySQL Workbench. You can download it from MySQL website. Once you set up an IDE, you are ready to start managing databases, designing schemas, and running queries. Now, let's start practicing SQL commands. For that, open the MySQL Workbench and start by creating a schema. We can create a schema with create command too. That's create schema and schema name. Right now, our database does not have any tables, so we should create some tables. Now we are going to create a customers table. Since we didn't mention any default schema, we should include the schema name in the query. That is why I included sales.customers instead of simply customers. Specify the column names as well as their data types. The semicolon at the end is not always mandatory in SQL. Even if it's not always mandatory, it's a good habit to use semicolon. Some database systems like PostgreSQL and Oracle require a semicolon at the end of every SQL statement. To set as a default schema, just right click on the schema name and choose Set as Default Schema. Now it's not necessary to include schema name in the create table command. We can simply use create table name. Here, the name of our second table is orders. As we did earlier, just mention the column name and their data type. Then run the query. Now we have two tables, customers and orders. I didn't add the primary key and foreign key while creating tables. So here I am adding the primary key using alter table command. I have added customer ID as primary key in the customers table. Here you can see that the change is reflected. You can perform the same action in a different way by right-clicking on the table and select Alter Table. Here I add primary key constraint to the order ID field. Another way to define primary key is during the table creation. Here I am showing an example how to define a primary key during the table creation. We defined primary keys in both tables. Now it's time to add foreign key. Foreign keys are crucial in establishing relationship between two tables. The foreign key links a column in the child table to the primary key of the parent table. Here the parent table is customers and the child table is orders. When you right click on the table and choose Alter Table, you can see a tab Foreign Key. Here you can see that the customer ID in the orders table, which is now a foreign key, is referencing customer ID field in the customers table. Right now our table is empty and we need to insert data into our table. We are using insert command to insert data into tables. You can insert multiple values at the same time. Once we run this query, our table will have entry for 3 customers. The syntax is like insert into table name, the keyword values, followed by the values that we want to enter. Then run the query. Now we can check whether our insert statement worked or not. So I'm going to fetch data from customers table. For that, I'm using select command. Suppose you are asking someone to get all the books from the shelf. You will say like, get me all the books. We are using the same logic here. We say like, select star from table name. Suppose you want to fetch only specific books. Then you will specify which books you want. Like that, I just want to fetch first name and last name from the customer's table. So, instead of using star, I just specify the column name that I want to fetch. Once we run the query, we will get a list of first name and last name from customer's table. Suppose you want to add some comments. This is also possible. The comments will not be executed when you run the query. When you want to fetch data that meets specific criteria, there comes the where clause. Here, I wanted to fetch the data for customer whose customer ID is 1. After executing the query, I got the details of customer whose customer ID is 1. Suppose you wanted to select only unique customer IDs. You can achieve this by using the keyword distinct. Just look at the result. It only contains the unique customer IDs. Just imagine you want the count of unique customer ID. You can use the function count. The order by clause is used to sort the result of a query. It can be sorted either ascending or descending, but the default order is ascending. Also, we can sort based on one or more columns. Here, our result is sorted based on customer ID. Now, try to fetch first name and last name from customers table and sort it based on first name, both ascending and descending order. Suppose we want to display full name instead of first name and last name. You can use the concat function. You can also use the plus symbol in order to combine two strings, but MySQL does not support it. Since we didn't mention any name for the result column, it's displayed as concat first name and last name, but we can mention the column name using the as keyword. Now look at the column name in the result table. It's displayed as full name. You can also create table from an existing data. I'm creating a separate database for that. For that, just right click on the table and choose Table Data Import Wizard and choose your dataset. Just refresh the view and see our table is ready. I just wanted to modify the table name to market. For that, I just right clicked on our table and chose Alter Table. And our table is renamed to market. Just have a look at the data that is stored in the market table. You can use select star for the same. We got plenty of data. I think we can use this table to perform complex queries. Now we can check how to rename a column. As we said earlier, the alter table command is used to modify existing table. Here I am renaming the column new market to market. Let's check whether our modification is reflected in the table. For that I am using describe. The column new market is renamed to market, but you can see the data type for the date created field is text, but it is supposed to be date time. So here I am changing the data type of date created field to date time. The alter table statement is used to modify the structure of a table, including changing the data type. Let's check whether our modification is reflected using describe statement. In our market table, the column market has values market 1, market 2 and market 3. Suppose you want to delete all the records of market 1. The delete statement removes specific rows from a table based on a condition. Here our condition is market equal to market 1. Here our table name as well as the column name is same, that is market. So it created some conflict. I had to run a command set SQL safe update equal to 0 to prevent this conflict. Then I was able to delete the records for market 1. You can see that 450 rows are deleted. Let's verify if the changes are applied. Another method to verify is using the keyword distinct. The query returned the values market 3 and market 2 only. So we can confirm that the records for market 1 is permanently deleted. Let's check the data in orders table. Now I am going to delete all the data in the orders table using truncate. Let's confirm whether the table is empty. The truncate statement deleted all the data in the orders table, but still the table orders exist. The truncate statement will delete only the data, not the table. So here I deleted the table orders using drop statement. If we try to access the orders table again, it returns some error. Have you ever heard the term joins? Just imagine, you want to combine the data of orders table and customers table. This can be achieved using joins. Joins in SQL are used to combine rows from two or more tables based on a related column. Based on the purpose, there are different types of joins. First one is inner join. Inner join retrieves the records that have matching values in both tables. And we have outer joins. Outer joins are classified into three: left, right, and full outer joins. The left outer join returns all rows from the left table, even if there are no matches in the right table. The right join returns all rows from the right table, even if there are no matches in the left table. The full outer join returns all rows from both tables, with null in columns where there is no match. Joins in SQL is a broad subject. Joins will be discussed in detail as a separate video. In this video, I am just giving you an introduction to joins. Now we can check how join works. Here I am combining the customer ID, first name and last name fields from customers table and order status from orders table. I used inner join for the same. In the results, you can see the customer ID, first name and last name from the customers table and order status from the orders table. As I said earlier, I will upload a separate video of joins where I will discuss it in detail. Let's conclude the video. Today we covered the basics of SQL, like creating and manipulating tables using create, insert, update and delete, and retrieving data with select and using clauses like where. We implemented the constraints like primary key and foreign key. We also covered the basics of joins. Thank you for joining this SQL tutorial. If you have any questions or need clarification, feel free to reach out. Just remember, the more you practice, the more confident you will become. If you found this tutorial helpful, consider subscribing to this channel. Thank you. See you in the next video.